All right, so now we are going to move on to next group of identity, okay? We're skipping one page, okay? We're not using this page today. We're gonna go to group 5, okay? It's called the double angle identity. All right, so everyone on this page, the title says double angle identity. So double angle, right? The reason why they say double is because inside, right, the sine, right, we have the sine and then double the angle, 2a, right? 2 is the double, okay? That's where the name comes from. So we also have cosine double angle, okay? We have the tangent double angle, and each of them has its own identity. Today we're just gonna focusing on sine double and cosine double, okay? Those are more common questions that you'll be given. So go over very quickly how those where those formula come from. Okay, identity comes from. It's based on sum and difference. Okay, so sine double comes from sine cosine. Cosine double comes from change sine sine. Okay, and I'll show you how, right, very quickly. And then in the same way, you can also prove the tangent. All right, so let's start with the first one. Sine double, right? Sine 2a. 2a means 2 times a. 2 times a is the same as a plus a, right? A plus a. So now you can see this is a sum, right? So I can use this sum and difference formula. Sine of a plus a is sine cosine. So sine sine, right? And both angles are a. So I just fill in a and a and a. And because it's sum, then the middle does not change, it's sum. Everyone follow so far? Okay, double means a plus a. And then I apply sine cosine. Okay, now sine times cosine should be the same as cosine times sine, right? These two part, sine times cosine plus cosine times sine. But because they are the same, I can just write it as 2 sine a cosine a. Okay, so how do we use it? What's the point of using the double angle? Sometimes when the angle they give you is not special, but after you double it, it becomes special. Okay, then we can use it to simplify. Okay, to find the exact value. So if you look at our first identity, right, sine 2a equal to 2 sine a cosine a. So let's say if, for example, okay, if I have 2 sine 15 degree cosine 15 degree. Okay, you compare this with, okay, compare this with the identity that we just found. What's the value for angle A? Jenny? If you compare the two green, what's the value for angle A?
I'm not sure.
Do you see the two green circles?
Is it 15?
Yeah, it'll be 15. You look at the spot, right? The 2 is at the front, and then sine 15, sine A. So A is 15. Okay? Do you guys follow how we got A equal 15? So because A is 15, then we can plug it into our formula, our identity. You're equal to sine double 2 times A. A is 15. Okay, can you raise your hand if you understand up to here, how we make it equal to sine 2 times 15? Okay, the yellow part should equal to the yellow part, right? We're working backwards. Okay, so this comes from here. Okay, we're using something that's not special, right? 15 degrees is not special. But if I double it, it becomes 30 degrees. That's special. And that thing we can find the exact value. Okay, so that's the purpose of double angle. Okay, we can make something that's not special, but by doubling, right, it becomes special. Okay, any questions? Claire, Evan, Joseph, Nick, and Susan? Okay, so even though we started with sine 2a, right, but the question will be given as 2 sine a cosine a, okay, and then you make it double. So it came from sine cosine, okay. Question B, not question B, second formula, second identity, we have cosine 2a. So same thing, we are gonna use change sign to show it, right? So we have cosine 2a, 2a is the same as cosine of what plus what, Angela?
A plus A.
Okay, a plus a, and let's continue from there, okay? Angela, you can carry on. If I want to use change sign, how do I plug it in?
Cosine A times cosine A minus sine A times sine A.
Yeah, very good. Okay, this is sum, right? We need to change. So the middle will become subtract. Right? Change, sine. And all the angles are the same. So they're all A's, right? Cosine A times cosine A, that gives us cosine A squared. Oh, this is the first time we see a square on the cosine, right? Minus sine squared. But writing a square and then have a bracket, okay, is too much work. So they just put square in between to show that it's a square of the whole thing, okay? So that's what it means. When you see a square in the middle, right, in between cosine and A, it means the whole cosine is being squared. So cosine double will be cosine square A minus sine square A. Okay, so that's our identity up there, okay? Our second one. And then from here, it derived two more, right? You see on the top, right? I circled the red. It comes out two more. Those two, to prove that, you need a different identity to help it prove it, okay? So we won't do the proving here. I'm just gonna go over how you can remember it so you don't use the wrong ones. So this one I'm going to add it to your list, right, of identity. So the first one here, it says 1 minus 2 sine squared, right? So I'll just put it right underneath, 1 minus 2 sine square A. Okay, the other one is kind of flipped around, right? 2 cosine square A minus 1. So what I would like you to do is to write the notes down first, okay? And I'll explain how you can remember it so you don't mix up the order, okay? So can you raise your hand if you copy down everything up to here? So both, actually all three of them, okay? Sine double, cosine double, tangent double, they can all be derived from the sum and difference formulas, okay? Sum and difference identities. Okay, please raise your hand if you finish copying. Okay, all right. So let's look at the two extra one, okay? How do you remember it? You can use the cosine square minus sine square, okay? Cosine square is coco, right? Minus means change, right? Sine. So you see the sine square is at the back. So you have sine square at the back, right? And then the other one, right? Cosine square just turns into 1. Make sense? And you need to add an extra 2. So the extra part is you need to have a 1 and a 2. Okay? You use the cosine square minus sine square to remember it. So sine square is at the back. So you have sine square at the back. All right? Now the other one, okay? The third one. Cosine square, you see the green part? Is at the front. So you have cosine square at the front for the third one. And the only difference is to add the extra 2 and have a 1 for the other part. Okay? So you just remember the yellow part, then you know the other 2. Understand? Okay, just little trick so you don't mix up the order. Okay? Should I put a cosine at the front or should I put a sine at the front? Okay, is it 1 minus 2 cosine or 1, right? Or the other way, right? So you just follow the same order as the cosine square minus sine square. Okay, do you understand?
Can you zoom out so we
Yep.
can copy it down?
Oh, you haven't finished? Okay, let me know when you're done. So we added 4 identities today, okay? So 1, 2, right? 3, 4, okay? 4 new ones. But they are all based on sum and difference, right? So like half new, right? So sine double, sine cosine, right? You get 2 sine co. Cosine double, co. So that's cosine square. Change Sine means sine squared, right? So it's similar. And then using that, we can get the other two. Okay, Jenny, are you done writing?
Yep.
Okay. All right, so let's go back to the list, okay? So we can get a quick reference. Go to page 1, everyone. I'm gonna fill that in. Our fifth group. Actually, in here on the list will be number 6, right? Double angle. We have sine double. Okay, Jocelyn, we are on page 1, okay? We'll fill in the blanks. Okay, we'll use, instead of A, we'll use theta, okay? Because usually we use theta to represent angle, okay? Sine double is sine cosine, right? Sine cosine, so it'll be double at the front. That's the first one. Cosine double. Okay, Justin, we're on page 1.
Okay.
Coco means cosine squared, change sine, so sine squared. Okay, and then from here we have 1 minus, right? Because I make one of them become 1 and put a 2 at the front, sine squared. Okay, so sine squared at the back, so you have sine squared at the back. The other one is to make the second term 1, and then the first one 2 cosine squared. Okay, you compare those 3. So cosine squared at the front, right? Coco. So you have cosine squared at the front. Okay? Just to help you remember the identity very quickly. So now we have 6 here on the top. We have 4 here. So total 10. Okay? So next time we're gonna quiz on these 10. Okay, if you finish writing, please raise your hand and then we're gonna try a few questions. So the quiz next time, okay, it will be writing, okay? You'll need to write these things out. Maybe half verbal, okay, half writing, we'll see. Okay, please raise your hand if you finished copying. Okay, Angela and Justin, still writing? Justin, do you need more time?
I'm done.
Okay, all right, so let's go to the examples now, okay? So what kind of questions can be tested here, all right? Let's look at, where are we? Page 70, okay? We're gonna look at page 70. So that's why you need to remember the identity, okay? Because otherwise you keep on looking back, okay? It's takes much longer, okay? So the instruction here is please express each as a single trig function. Okay, let's circle that. Single means only one, right? Trig means sine, cosine, or tangent. So either everything you make it into sine, or only cosine, or only tangent. So you can see the first question, you have a mix of sine, cosine, right? You want to turn it into just one. Okay, that's our goal here. After that, find the exact value. So exact value means the sides, okay? Side ratios. So like root 3/2, right? -1/2, that kind of things. Side ratios. Side ratios. Okay, so you ready? Let's look at the first question. I'll break it down into 3 steps, okay? So you can just follow that for every single question. So when you are given a question like this, right? You have 4 sine pi over 12, pi over 12. These things, the pi over 12, they are theta, right? They are the angle. Or you can call them the A, right? This is the A, right? Angles. Okay, just keep in mind they're just angles. So we have 4 sine A, cosine A. So first, you want to choose your step 1. Choose the identity. Okay, so can you pick, oops, I think I just closed. Okay, can you pick the identity that looks closest to this one? Okay, from the last 4 that we just covered, which one looks the closest to this question? Okay, if you have an candidate, please raise your hand. Which identity looks closest to this one? Is it the sine double or the cosine double? Yeah, Eric?
Is it a sine double?
Sine double? Can you tell us what's the identity for sine double?
It's 2 sine A cosine A.
Yes, okay. So 2 sine A. So first thing is to pick the one that is closest to it, right? Because the question won't be exactly the same, right? 2 sine A cosine A equal to sine double. Okay, so you compare the question and the identity. Okay, so first you got to pick the right one. Don't pick the cosine double, right? Cosine double has a square. It doesn't have a square, right? So it'll be this one. So that's your step 1, okay? You have to pick the right one. Step 2 is to modify. Okay, modify the identity that you just picked to match. Okay, to match the question. To make it look the same. So you want to modify 2 sine cosine, make it look like 4 sine cosine. Okay, how do we make 2 become 4? Anybody? How can we make the left side, right, 2 sine cosine become 4 sine cosine? What can we do to the left side? Anyone?
Multiply by 2.
Multiply by 2, very good. Okay, so we're gonna take the left side Okay, this identity I'm just copying again. We're going to take the left side, multiply by 2. So of course, the right-hand side, you have to do the same thing, right? Whatever you do on the left side, you have to do the same on the right side, so you don't change the question. So both left and right side multiplied by 2. So you will get 4 sine A cosine A equal to 2 sine 2A. So now you can see that the left side matches the question, right? Any questions so far? Can you raise your hand if you understand what's going on here? You pick an identity and try to make the identity looks like the question. Okay, Caleb, Daniel, Jenny, Jocelyn, Nick, do you have any questions?
No, I just forgot to raise my hand.
Okay. So once it matches, right, then you can see the angle A, okay? How big is our angle A then, Evan? What's the value for angle A?
I'm not quite sure.
You compare the green circle, okay? The one, okay, I'll use highlighted, okay? The green one, the yellow highlight, right? And this yellow highlight, you compare those two, they look the same, right?
Yeah.
Okay, so what do you think the angle A represent? Instead of A, what do we have in the question?
Oh, pi over 12.
Yeah, pi over 12. We just look at the location, right? The position of A, right? 4 sine A cosine A. So instead of A, we have pi over 12. 4 sine pi over 12 cosine pi over 12. You just compare, that's all, okay? There's no special trick. All right. So once you recognize, all right, now it matches and our angle A is that, the final step is to sub value into A. Okay, sub value for A. But first you need to recognize A has to be pi over 12 for this one. So this is the question, right? I'll copy the question one more time. Okay, I know the A is pi over 12, right? So I sub it in. So equal to 2 sine of 2 times pi over 12. This part is this part. Got it? Okay. The yellow part is the yellow part, right? All the yellow matches, okay? And the purple underline matches. Okay, so the left side is the question. Because of the double identity, right? It become a single, right? So now it become only one. To simplify that, 2 sine of pi over 6, right? Because 2 times pi over 12 is pi over 6. So that is the answer we want to have. This is called single trig, right? You only have sine now. Does anyone have questions of what's going on? I explain very, very detailed here, okay? Step by step. Of course, in starting next question, we're gonna speed up a little bit, right? This is our first question. I want to make sure everyone gets it. All right, any questions here? This is called single trig. Okay, can you raise your hand if you copy everything down? So every question will be doing the same steps, okay? Pick an identity that works and try to match it. And then you just sub it in, that's all. Okay, please raise your hand if you got everything here for question A. All right, so for B, are we ready for B? Jenny and Justin, are you done copying? Okay, so for B, we have 6 cosine squared pi over 8 minus 6 sine squared pi over 8. We want to pick the identity that match. That's similar, right? Looks close to it. Anyone has a suggestion? Which identity should we pick?
Cosine double?
Okay, cosine double. Cosine double, we have 3 of them, right? Inside cosine double. Which one is it?
Cosine. Wait. Cosine squared minus sine squared.
Okay, very good. Okay, so because this one has a square, right? Has a square. Okay, cosine square minus sine square. So we'll pick that one. Okay, so our first choice, cosine square A minus sine square A equal to cosine double. Okay, so that's our step 1. Pick the one. Step 2, we want to make this and match the question. Okay, so you compare the question with the left side, right? How do we make the left side look like the question? Okay, remember it's to match the question. Do not change the question, right? Okay, so let's see, Lily, what can we do on the left side so it can look like the question?
Multiply by 6.
Very good. Okay, it's just missing a 6. Okay, so both sides multiply by 6. Okay, so if we do that, the left side will look like 6 cosine square A minus sine square A. Oh, 6, don't forget 6, right? Same thing, we have to multiply the right side. 6 cosine 2A. Remember the 2A, you cannot multiply that by 6. Okay, whatever that's angle, you can never touch it. Okay, angle never change. Right, whatever you multiply, it doesn't change the angle. Okay, so now the yellow part matches the yellow part, right? Look at all the yellow. Okay, I think too messy, too many circles. Just erase the circles. Okay, so yellow matches the yellow. We can move on to step 3. Sub. Okay, what's the value of A then? Marcus?
Pi over 8.
Yeah, very good. Okay, everything else the same, right? A has to be pi over 8. Okay, so I'll sub pi over 8 into A. So I will have 6 cosine squared pi over 8 minus 6 sine squared pi over 8 equals, okay, what will be on the right side now? Caleb?
Oh, could you say that again?
what's the value on the right side? What do we put on the right side now?
6 cosine of 2 pi over 8.
Right, 2 times pi over 8, okay? It's multiplying in between the 2 and the 8. And we'll simplify that, okay? Very good. So 6 cosine, okay, what's 2 times pi over 8? Nick?
Pi over 4.
Yeah, pi over 4, okay? So if you are able to multiply together, simplify it, make sure you do that, right? So this is the final form you want to leave for your homework, okay? So you started with a cosine sign, and then you turn it into a single, right? You only see cosine now, okay? You see all the yellow highlighted, right? The yellow part has 2 of them. After you simplify it, becomes single. Okay, so let's look at question D. Okay, can you raise your hand if you're ready to move on to D? So of course, after you get to the single, then you can figure out the ratio, okay? Cosine pi over 4, you can find out it's 1 over root 2, right? And then you multiply with the 6, okay? Simplify. So that part is how you get the exact value. Okay, Eric and Evan, are you done writing? Okay, let's work on another one here. Okay, so we have question D, 10 sine squared 3x minus 5. Okay, which one looks closest to it? Anyone has a suggestion? Which one looks closest? Yes, Eric?
Is it the 1 minus sine squared A?
1 minus what?
Sine squared A.
Do we have that? Double check your identity. 1 minus what?
Oh, 2 sine squared A.
Yes, okay. 1 minus 2 sine square A equals to what? What's on the right side?
Is it cosine 2A?
Yeah. So it's the cosine double, right? So if you compare this left side with the question, it's close, right? They both have sine square, right? They both have a minus, right? However, the order is mixed, right? It's flipped, right? Because the sign in the question, the sine square is at the front, but then the identity, right, is at the back, okay? So remember, we need to match the question, okay? So do not change the question. You only modify the identity. So we want to do something to the identity to the left side so it can become the question, okay? Does anyone have a suggestion? How can we modify it? So then the sine square can go to the front. Anyone? How can we do something to both sides? I usually want to do something on both sides so it can match, right? Sophie, what do you think?
Multiply by -5.
Multiply by -5. Okay, let's try that. Multiply by -5. Okay, so left side times -5. Okay, right side times -5. All right, so -5 multiplying, you get -5 plus, right? Because negative times negative, 10 sine square A. Okay, right side is -5 cosine 2A. So now because there's a positive 10, right, in the middle, so I can swap the order, make it into 10 sine square A minus 5. Okay, very good. So if you compare the question, right, compare the question with the identity, the sign's opposite, right? The sign square in the question is positive, but the identity is negative. So that's why you need to multiply by a negative sign. So now the yellow part matches the yellow part. Okay, final step. Okay, this is a hard one, right? Because the order is mixed up. So you need to times by a negative number. At the same time, you need to match the value, right? Turn the 2 into 10. Okay, so what's the value for A then? Claire, what's the value for A?
3x.
Yeah, 3x. Okay, so this time is not a number. Okay, it's just an expression. So sub 3x into A. Okay, so we'll have 10 sine square 3x minus 5 equals -5 cosine. What goes in here now, Jenny?
Is it 2 and then 3x?
So 2 times 3x, right?
Mhm.
What's 2 times 3x?
6x?
Yeah, so you just leave it as 6x, okay? If it's possible to simplify, you always simplify it. So this is, again, once again, this is called one trig, okay? Single trig. Okay, so that's as far as we can do today, right? Okay, but you get the idea. Every questions, you follow the same steps. Some of the question might be harder. You need to swap orders. Some of them, it's not always multiply. Sometimes you might need to do dividing, okay? So it's either multiply or dividing on both sides. Try to make the question match, okay? So that's all for today. I'm still missing 5 homework. So you know who you are. Please stay after class, okay? Or I have to call you, okay? All right, and the rest of you have a good weekend. And Kellen, please stay after. I need to get your homework 17, okay? All right, so see you next week.
Bye.
Bye-bye.
Thank you.
You're
Hey,
welcome.
Jason,
Yeah, Jenny.
I left my homework at